recent trends in artificial intelligence and cyber security. First of all, I like to convey my thanks to you. Join with us to share our knowledge. Before entering the session, first let me introduce about you, madam. It is my honor to introduce Dr. DrRKavitha. Currently, Dr. Kavitha is working as professor at Welltech, Chennai. She had 14 years of teaching experience. She received her master's degree in software engineering from College of Engineering, Anna University. She received PhD in computer science and engineering from Welltech, Chennai. Her research areas are machine learning, image processing, and software engineering. She had guided many UG and PG students. She is recognized supervisor at Welltech University, and she is guiding 8 research scholars presently. She published more than 30 papers in reputed international and national journals. She is an active member in professional societies like IEEE. She had delivered technical sessions to various reputed institutes. She has been a reviewer member for many international and national conferences and served as technical committee member and sessions chair also. It is our great honor to have great person in this FDP as a resource person, madam. Now I request you to share your thoughts in this FDP, madam. Please.
Thank you, ma'am. Thank you so much. Okay, good afternoon, everybody. So I'm going to deliver the session on data science and machine learning landscape. I once again thank the in-charges who have organized this session and given me an opportunity. So with that note, I'll just start my session. I hope I'm audible. Fine.
Yes, ma'am, you're audible, please.
Thank you. So before going to the session, I'll give an overview on the agenda, what I've prepared. So this session will give you an idea about, we are going to talk about the data, and it is going to be a session, a very basic session on introducing about what is data science, about machine learning, what are they, what are the concepts, mathematical concepts behind it, and what are the different applications that can be completed by the data science or machine learning techniques. And also we are going to discuss about the tools and various other techniques. And it will be an orientation towards the data science and the machine learning landscape. So let's see, the major thing what we have to understand about is about the sources of data getting generated. We could see an enormous amount of data getting generated. And this is a slide which tells you about, in a minute, like what are the various applications that generates the data. We could see an enormous growth of data because of all the medias what we have today. So data refers to a fact, and because of the enormous data what we have, we could think about the techniques in order to plan well defined for our future. So that is what the data science does, and also about the machine learning. So in the before case, if we think about leaving the data science apart, we could see we have our business intelligence, which does the same job. So with the data, for example, if it is a data that is going to be a structured data, which is available in Excel, we are going to think, how do we handle it? How do we store? How do you identify to understand what is going to happen in the past? But now in the recent trend, we could see because of the growth of algorithms available and because of the techniques available, we wanted to jump into a new buzzword called the data science, which is going to be applied for not only for the structured data, which is also going to handle unstructured data. And we are going to talk about so many tools that came into picture that is going to handle the data and make the algorithm in an efficient way. So this is a diagram, a Venn diagram that talks about what is the relationship between your data science, data analytics, and data mining. So data mining will be a very basic thing wherein we'll talk about the algorithms. Is my screen shared?
Madam, you need to share the screen again.
1 second.
Yes, madam, your screen is visible.
Okay. So we are going to see about like what is data mining exactly. Like we were talking data mining in the past where it had very traditional algorithms, and then we talked about the data analytics. We came into how do we handle a large amount of data and how do you find the analytics over it. So all these things put together, we have something called data science, where we concentrate more on the data, leaving the prediction model or what we are going to see in the machine learning part. And this is like, how do we find a relationship between your artificial intelligence, then coming to the machine learning and deep learning, how the data science is being a part of it. So AI, we talk about adding intelligence to a model, where in machine learning, it is being done through a help of algorithm, and deep learning, we could see because of the existence of and the advancement of neural networks, we could see a very good evolution happening in case of the deep learning. So altogether, why data science is involved here is it all talks about the data. It will identify the data and it will do a good work on identifying the insight from the data. So once the data is there in hand, then we could go to let it be an AI task or ML task or DL task. So what we require is to understand what is data science exactly. So let's understand about the data science. So people can think like very in the earlier times we are talking about the data science, but it emerged during the year 1962. We are talking about the statistics. So for the data science, the statistics was the foundation. It made a very strong foundation so that we think about the data science algorithms today. And again, in the 1980s, we could see the development of computers to aid the data collection, wherein we wanted to collect the data in order to do something with the data. And now we are talking about the recognition of data science as an emerging field, and we could see a very good scope for the data science today. So what exactly is data science? So we are going to discuss this as an interdisciplinary field where we are going to talk about how do we create an algorithm and model to extract only the data. Like for example, if we have a data, we'll be thinking to identify the insight from the data alone, not for thinking about the model and all. We are going to just see what is the efficientness of the data, what we have in hand. We are going to see about how do we handle those data in order to make our model more efficient enough. So this data science comes with the four important models. We are going to talk about the data exploration. How do we explore your data? How do you visualize your data? And how do you do all the pre-processing stuffs? Then we'll be talking about the model development, modeling. How do we model a data? So that again, we are thinking here like our task is only to deal with the data. And then we go for model testing, test your model, what is being developed, and then go for deployment of the data. So all these four are the very important concepts, process involved in the data science. So why do we require a data science? What it is going to do? So all these data science concepts, if we deal with, it is going to give us a better decision making. We can even think with the data what kind of task can be involved. and we are going to see about what will happen in the text. That is what called as the predictive analytics. And then we are going to see about the pattern discovery also. What are the insights? What is the pattern that is being there inside the data? Once we do a very good analysis over the data, then that analysis will help us to make our model in the better development way. So these are the three important ways in which you can proceed over any task which you wanted to do with the data science. First one is asking the right question and explore the data. Find whether the data what you have in hand is the right amount of data, and it talks about the idea of what we wanted to do. And then we think about the modeling of the data, which is going to happen using the algorithms. Various algorithms are there. You can deal with the machine learning algorithm or AI algorithm. Only the data science is going to help you about modeling the data. Then finally, we are going to visualize, called it, we can use any of the EDA called exploratory data analysis in order to visualize your results. It can be in terms of reports or it can be in terms of graphs. So let's take a very simple example. Suppose a user wanted to buy a furniture. So what we could do is you can think about how do we handle the data and how do we transfer the data in hand in terms of an algorithm. For example, if this is a task what we wanted to do, then we can think about, does the website sell the furniture? So what we can do, you can find a list of furnitures, online websites what you have in hand, and then you can find out how many of the rating is good and how many of the rating is false. Then again, you could do a further analysis, and this is what we call it as a decision tree. So with the data, when you have a model like this, then easily you can identify whether you wanted to follow the path. Like for example, your website sells furniture, then you go for whether the rating was less than 4 or out of 5. And then you can identify whether you wanted to go with the websites that is providing the discounts or not. So that is how you can find out whether you wanted to purchase a product in a particular website or not. So instead of seeing the data in terms of rows and column, you could also see it in terms of a visualization where you can decide and make your prediction in the easier way. So now why we need to talk about this data science is because you could see the future depends on the data science and AI and also about the machine learning. And we are going to do a lots of things like, for example, in the earlier we were talking about what happened, which is given by the descriptive analytics. Then we were talking about something called diagnostic analytics, which will happen in the healthcare. Like why did it happen? What is the reason behind it? Only all can happen only with the data what we have in hand. And then this predictive analytics came into the picture when we seen the emergence of ML. And now we are going to also see how can we make it happen. Based on the data, we can do something if we wanted to make it happen. That is being analytics. And this is the survey done by the Gartner. So this is the data science life cycle. Like we are going to see the first phase is going to be a business understanding. How do we handle a business? How do you make a requirement feasible? And then we go for a data wrangling, and then we have a phase called EDA. So all these data wrangling and the exploratory data analysis deals with the preparation of the data. And then we move on to the model development. You can do your statistical modeling, then do for creating a model, train your model, test your model. You can apply any machine learning algorithms over here. And then finally you go for data visualization. So here we require a model only to visualize our data or do something with the data alone. Your data is not going to be applied for modeling for a prediction thing. It is only to deal only the data in order to understand the data in a better way. So what are the phases, like how do you conduct a business understanding? You could see, you have to discuss about the data, you have to identify what could be the category you wanted to fall under, what could be the group, or what are the different questionnaires you can conduct in order to understand your data. That is your business understanding. And then you go for the data wrangling, which is very in simple words, it is called as in data pre-processing, where we pre-process our data so that the data is ready to get processed. And then we have our EDA, wherein we'll be doing your EDA process on doing a univariate analysis or a bivariate or a multivariate. It can be a binary classification or it can be a multi-class classification. So those things can be done in the EDA phase. And then we go for statistical modeling, wherein we use backend statistics techniques in order to model the data. And then finally, you end up the process. So coming to the life cycle of your data science, you could see you can map any of the data science application with the phases what we have seen just now. For example, let it be a sentiment analysis. You can take over the data. You can do your business requirement phase, and then you can go for your data pre-processing, then do your statistical modeling, and then you try to visualize your data. So what are the important math that is behind the data science? We'll see a very basic glimpse on it. So first, very important thing is you have to understand about the statistics, which is mathematics that is behind your data, like how do we visualize our data, how do we collect your data, how do we analyze and interpret your data. That is what we could see do in your statistics. There are various statistical methods that are available. And before that, let's talk about sampling. What is sampling? Sampling is like selecting the group of data in order to conduct an experiment over it. So there are two ways in which you can conduct a sampling. One is based on probability. The other one is based on non-probability. So very few methods I'll just show you. So this is called as random sampling method. So you could see these are the samples what we have. This is our population. We call it as a population. From a population, randomly, if I choose some sample, that it becomes sample. So what is the benefit over here? Like, for example, I need not depend on the total population. I need not conduct an experiment on the whole data what I have. I'll take a sample of data and conduct the experiment. So the experiment what you conduct for your sample, it is very similar to the data what you handle with your population. It is all because we do experiment in an easier way. And this is systematic sampling method. We follow a systematic procedure. We have a clear-cut protocol in order to conduct the sampling. And this is stratified sampling method. I put a group on different clusters. I'll make different clusters of data, and from every cluster, I take one element. That is called a stratified sampling method. And coming to the types of statistics, you all may be knowing like what is inferential statistics. Then you have descriptive statistics, under which you will be talking about the central tendency and the variability here. So what is this descriptive statistics? So for example, you could see your raw data here. This raw data can be transformed or interpreted in terms of graph. So by the graph, we could also see how easy it is for us to interpret the information rather than coming to the raw data. So that is called as a descriptive statistics. And under the descriptive statistics, you could see and measures of central tendency. You can either go finding the mean. For example, if you have a missing data, how do you fill up the data with the missing? You can go with your mean value, or you can go for your median and mode. And measures of variability, how do our data vary in a particular column? It can be a range, we call it as range equilateral range. Then what is called as variance. What is the range of data that is being spread, and the standard deviation results. So all these are the mathematical terms which we come across when you do your analysis on the data. Inferential statistics is, again, need not worry about developing an experiment on the whole data what we have. We could select a sample of data, conduct our experiment, and the result could be applied over the population of data what we have. So this is the information gain and entropy, which are the metrics that will be used. So this entropy will be a very important thing. Like it can be used either in your machine learning or decision tree, all those things. So entropy basically means like how do you take a sample of data. It all means like what is the proportion of the data samples what you have chosen. For example, if you wanted to think about binary classifier, I'll be having two class labels, class A, class B. So what is the amount of classes you have chosen from the class A and class B is all about the entropy. So you could see the entropy lies between 0 to 1. If you take only one particular sample, then it becomes the entropy will be 0. And if it is being managed, balanced between all the class labels, then you could see your entropy will be 0.5. So when you conduct an experiment, the data what you choose in hand is very, very important. And you have to make sure that the sample what you've chosen is efficient so that you can go for the further step, and also you could see a good result over it. And the other mathematics, what you have to understand is about the probability. Like some cases you have to depend on the probability in order to judge what could be the value over it. So you should be knowing what is probability, like is measure how likely an event will occur. There are few algorithms also that depends on the probability, like you have your Bayes theorem, the Bayes theorem. So these are the few terminologies in probability, like what you have to understand what is sample space and what is an event. So coming to this probability distribution, there are three important things you have to understand about the PDF called probability density function. Then you have your normal distribution and the central limit theorem. So having your hand, you have to understand what is the distribution of data we have. Like how do you identify the probability density function and normal distribution, whether our data are normally distributed, which is having what is the mean of the data we have, what is the standard deviation we have. So this is the plot that shows about the normal distribution. And this is central limit theorem, which is from the diagram you can easily understand when you increase your sample size. When you increase your sample size, you could see the density of your data makes it in the top. Okay, so what you have to understand here is you have to increase the number of samples. The moment you increase a sample, because the lesser the data, it will not give you any good result. More the data, you could do some analysis and identify the insight over the data. So Bayes theorem is based on the event of one entity. We are going to identify the results of the another event. That is what your P of A by B does. So based on the conditional probability, we can identify the occurrence of one event is going to give us a probability of the another event that will be occurring or not. So this is point estimation. You could see we have a single point, which is going to be a number, wherein if you talk about the confidence interval estimates, it is going to be a range of data. Like it talks about range 1 to range 2, and it is going to give you a interval. Then hypothesis testing is a very important task what you have to conduct before you draw conclusions. So first is you have to set an hypothesis. So any experiment you wanted to start, any business requirement, whatever you have to conduct a hypothesis testing, formulate a hypothesis, formulate a statement, and then collect the data over it, analyze the data, test what is the idea of the statement, what you fixed is going to work out or not. Later, you identify the conclusions. So once you conclude, you can either stick on whether the hypothesis chosen by you is going to be proceeded or not. Otherwise, then again, you have to go back, change your hypothesis and proceed this process. So this process will tell you whether to start a problem, what you wanted to initiate. So coming to the data science skill set, you could see like you should have a very good background on the statistics. Good programming language like Python will be a very basic one to get into. Then you have so many tools available for the data exploration and data wrangling also. And you can also go for machine learning algorithms. So these are the required data set, skill set. So coming to the machine learning, we are going to just see like what is the need of machine learning. Again, because of the data, like the enormous amount of data getting growing like every day, you could think about what you can do with the data. So what you can do with the data is you can plan your future, or you can do some predictions. So that is what we go for your machine learning techniques and algorithms. So we are going to see like how do we improve our decision making, how to solve complex problems, and also how do we find the patterns from the data. That is what your machine learning algorithms will do. So traditionally, you could see like when you do any traditional programming, you require a data and program and you get your output. Whereas here, in your case of your machine learning, we are going to take our data and the output, which you are going to identify a program over it. So this program, we call it as a model. So this model is going to work for any data and will give you what is going to happen in the future. That is what we call it as a predictive outcome. So we take a data, you try to train your machine, you build a model, and then you go for predicting the output. So there are two important categories of machine learning, especially we call it as supervised learning and unsupervised. Under the supervised, we talk about the classification and regression, and then under unsupervised, we are going to discuss about the clustering. So reinforcement is the another type of machine learning where we talk about the how do we program an agent. So in the supervised learning, we are going to see like what is the data we have. So in the supervised learning, you have to ensure that the data are getting labeled. Once the data are labeled, then you give it to a machine learning where you put an algorithm to decide what are the since we have a label, we can supervise and find out, make a model to train in order to identify that any new data you give, it will identify what is the label of it based on the data what we have in hand. So that is called a supervised learning. The learning is happening based on the labeled data. Whereas in case of unsupervised learning, we don't have a labeled data. We have all unlabeled data. In this category, we are going to apply an algorithm in order to group the data, which is called as clustering. We cluster the data based on their similarity measures. So this is a very general machine learning process. We are going to train the model. This training is a very important phase because training phase makes the learning process. And then you try to do your pre-processing, then go for your model building. And finally, after the result, you go for your data visualization. How do you visualize your model? So what is this learning process? So any learning process, it is going to happen in this way. For example, if you show any object, first of all, we have to understand what it is. So when I deal the same thing in terms of computer, I'm going to give you a response. If my system is going to give me a response, I have to give a feedback to it. No, it is not an apple. This is called as learning process. What I'm doing is I'm taking any object and giving the information to a machine to understand how it will identify that object in the near future. And now, because it had learned that it is not an apple, it is an apple, so it could easily do a learning. So initially it was telling the response as mango, but we have made a learning to the system to understand that it is apple. So this process will be continued in order to complete the learning so that later any new data you give, it will give you the correct result. So this is a real use case, like how do we think about a use case and how do we bring all the concepts what we have seen well before. So let's take an forecast model. We wanted to take, let it be dengue or it can be a COVID also. So first thing what you have to do is about thinking about the data source. How do we get a data? Because with the data, we can go for conducting a model. So what are the data sources wherein we can collect your data? Then this next step would be the data preparation. Once the data you have downloaded, you have to clean the data, conduct a feature engineering wherein we identify the features and do the feature selection process. And then you go for the data re-preparation wherein you identify whether it is going to be a structured data or unstructured data, what is the type of data we have. This is not a mandatory step. And then you go think what could be the learning we can apply over, whether it can be a supervised learning or unsupervised learning. Once a model is being made, then we go for evaluating the model. What is the accuracy or what is the performance of the model what I have built? Then finally, once the evaluation results are better, then you can think on the deployment of the model. So these are the various machine learning algorithms we have today. Like there are few algorithms which are traditional, there are few algorithms which are emerging every day. And you could see like in the classification, we have SVM, which does a very good job. And in the regression, you could see linear regression and neural network, which are doing a very good job in terms of classification and regression. And similarly, in case of clustering, we could also see our fuzzy and Gaussian mixtures and HMM model also. Very popular. All these are very popular. So this is about the bias and variance trade-off. Like the moment you take your data and if you want to apply into your model, you have to see what is the performance of my model is going to be, how better it is going to give me the result. It is all based on the data what you have in hand. You will be coming facing few problems. We call it as underfit and overfit. So what is underfit? When you don't take your sample properly or when your model does not make a proper learning, it becomes underfit. Overfit is your model tries to consider all the data, even it is going to be an outlier or a noise, it will consider and make the classification. So that becomes overfit. So you have to ensure that your model is going to be a fit. So that is a point we call it as an optimal model complexity. You have to ensure during the training of your data. So the same thing here. So what is supervised learning? Let's see like what are the algorithms that comes under supervised learning. So first one is a linear regression, wherein you have to identify a linear line that separates two different classes. So all these points are the classes and we have a line that linearly separates. The line should be straight. In terms of your logistic regression, you could see both does this regression job only. Regression will be applied for the continuous data. So here in the logistic regression, it all depends on the data what we have. For example, in the linear regression, if I have yes or no class labels, it is easy for me to segregate two. Whereas if it is not in that case, it is going to be a continuous, then you have to see all the outliers also. I need to consider the outliers also. The threshold value is also very important here. So it cannot be linear, it will be in terms of a sine curve. This is the difference between your classification versus regression. Regression, you have a straight line that linearly separates two different classes. Classification does the job based on the data samples what you have in hand. So decision tree is one of the traditional classification technique we have. So based on the tree, based on the data what we have, the data will be considered as a tree, and then you go for finding the classes. So now I can, the data what you have here is being converted into a tree, and from the tree for any new data you can apply and you can traverse over the tree and find out what is the class label for any new data. So how we have prepared this decision tree is based on the data what we had, but we don't know what will happen in the future. We don't know what is the data, what will come in the future. So for any new data, any future data, this tree will be a more appropriate one. That is what we do in the machine learning. And this is random forest, wherein instead of making one tree, we'll go for a number of trees and find what is the, based on the voting, we decide what is the best tree, and then you go for the particular tree. And one more thing, we call it as KNN, based on the nearest neighbor, we assign the class label. What we do really is based on the data what we had, all our class labeled data. Based on the labeled data, any new data you get and do the classification. So this has been done by the distance measure. So any new data, we'll see the distance and based on it, we'll assign the class. So this is a naive Bayes, which probably uses the Bayes probability theorem in order to find the event of one event based on the occurrence of the other event. So here it applies a probability measure in order to identify whether the particular class can be assigned to class A or class B. How do we assign the data based on the probability measure? And then coming to neural network, like you have to understand what is single layer perceptron, like what is a perceptron. So we have your input layer, we have our output layer, you have your hidden layer. So this is, we call it as a neural network. So the inputs are already known to us, the output is also known. We try to create a structure in between the input layer and the output layer. So here we have one input layer, two hidden layers, and one output layer. So this is a part of a perceptron. You have your input layer. This is the input sum, and you have to find the activation function, then decide whether a particular neuron will be getting activated or not. So this is the activation function. So these are the weights, initial weights we give. They then go for the summation, and then you apply the activation and find whether the neuron gets activated or not. So this is an example of neural network. You could see, like, we wanted to train a neural network for making it identify whether it is a cat or a dog. You could see for a cat, you have several other neurons getting activated, and for the dog, you have the other structure of neurons getting activated. That's how it identifies whether it's a cat or a dog. And the weights will be initialized. Initially, we initialize it, and then we try to update it. We call it as forward propagation and back propagation. That's how you conduct your neural network. Under the unsupervised learning, we are going to see about like how, based on the distance measure, since we don't have the target class label, what we do is we do clustering. We group them into different clusters based on the distance measure or based on any similarity measure. So there are two categories in which you can find the types of unsupervised learning. You have parameterized thing and you have non-parametric thing. So this unsupervised learning also deals with the association. One thing is your clustering. The other one is association, wherein how do a object associates with another. Under the clustering, so you could see these are the data. We apply the algorithm, any kind of clustering algorithm on which it is going to provide you two different clusters. So what we have to understand in the clustering is when you make two different clusters, the data what you have inside one cluster will have a similarity, and when you compare a data from one cluster to another cluster, it will not show you a similarity. These are the different types of clustering. We have hard cluster, soft cluster. So when you do this clustering, you could see every data belongs to one particular cluster. But when there is a merge, we call it as a soft clustering. So there are two different types of clustering algorithms which comes under hard cluster and when it comes under soft cluster. And you could also see like within the cluster, the distance should be, like the similarity should be high, and when you compare from one cluster to another cluster, the similarity should be very less. And these are the different types of clustering. We have hierarchical, then you have k-means and KNN. Under the dimensional reduction, we have PCA, then singular value decomposition, and independent component analysis. So under clustering, you have different types. You have the agglomerative, which is a hierarchical clustering. We have overlapping called fuzzy C-means. So this is your example for your K-means clustering. Based on the K value, what you decide is you decide about the cluster. And this is a technique in which you identify why it becomes to a cluster called A or B. So these are the data points we have initially. You can take any two data points given as a cluster center. So now we consider the two given centers are centers of the cluster, and then based on which you identify like how it belongs to the particular cluster or not. Then again, once a few data points are added into the cluster, your centroid changes, Again, you update your value, and the process will be continued till the cluster does not move from one cluster to another cluster. That is how you do in your k-means clustering. In the hierarchical clustering, you have two cases. One is agglomerative and diversive. So this is a hierarchical clustering, which initially you can take every data as a cluster and try to identify the two data which are closer to each other. That is going from lower end to the higher end. Same way we can come in the opposite direction also, like you can come from the top to the bottom approach. So that is us. And there are few linkages also in which you apply your hierarchical clustering, like either you can go for your single link or complete link or average link. It all basically different ratios what you wanted to consider to conduct your hierarchical clustering. So coming to the data machine learning, like what are the algorithms that basically comes under your decision tree is you can go for your regression, clustering, decision tree. And let's discuss some of the applications which are unique in case of your machine learning as well as your data science. So this is one particular application. You could see your how do we identify a image, like how do we understand like the first picture is going to be a opponent A or opponent B. How do you identify a player, what is his country, how do you identify a player, and sometimes you could also see like where the ball is going to be and what is the pattern of the ball. So all these comes under the sports. And in the banking and finance, there are various applications that can suit. Like you could do real-time analytics, you can go for fraud analysis, you can go for your customer data management. There are various applications. And similarly for the education, you have enormous applications that can be applied in order to think about the curriculum development and to go for student enhancement. And as far as healthcare is concerned, you could see because of the emergence of your ML and the data science algorithms, many expert systems have been developed, and because of it, you have a very good improvement in case of the healthcare. So with the data only it is possible. And similarly in the internet search, how do we identify all these search, and how could you see so much of results that is based on the given search keyword. And digital advertisements is also one of the emerging application. Then you have your recommender system. How do Netflix identifies what is a movie you wanted to watch now, and what are the recommendations you are getting based on the history what you have been. And this is under the image processing. How do you identify the number plate of a vehicle? What is the speed of the vehicle moves? Similarly, for the speech recognition, self-driving car, IoT. So coming to the tools and the skill set. So what are the required tools that gives you an idea on doing some projects or doing some research on data science and machine learning? It's going to be like you have enormous Python libraries. So Python could be a very good platform for you to work or to explore more on the data science and machine learning problems. So under which you have to understand what are pandas, like it's in Python library. Similarly, you have to have an idea on the NumPy, doing numerical problems. And similarly, you have your SciPy also, which basically does what are all the mathematics behind the data science and machine learning could be done by using all these packages. So it is all predefined. You all have your methods. Then you have your matplotlib for especially for the visualization. How do you visualize your data? How do you find your data pattern? And about the evaluations also. And these are tools for handling a volume of data. Like when you want to deal with a large number of data, like large volume of data, you could see Excel also comes with the latest version of Excel comes with the improved, where it also gives you a way on handling large amount of data. and you have your Microsoft Access, then you have your MySQL. Then Hadoop, if you want to work on unstructured data. But now you could see Apache will be the one popular one that works on it. So Apache, Storm and Kafka are the popular tools today in industry. And similarly, like Apache Flink and Kinesis also, they are the very popular data science tools that are available today in the market, and most of the industries depend on these tools. Like you have Tableau, which is a very good data visualization tool. You have some BI tools also available, Power BI, and Google also comes with their Google Analytics. So these are some of the Python IDEs available for the data science. So PyCharm is a popular one among it. And what are the roles and the job market available today? Is like you have various roles for the data science engineers if you want to emerge, or if you want to shift your career, or if you want to orient your students to decide on their path in the data science. You could tell them like you have several roles today called data engineer, visualization expert. So what they need is about the knowledge and the skill set, what I have told. So you have various data roles also, data science roles and skill sets available. As a data engineer, what are the track they have to design? As a software engineer and as a data scientist, what are all the knowledge and the skill sets required? And this is like, how do we differentiate data scientists with data engineers? Data scientists totally they deal only with the data, and they see the background, the mathematical background behind the data. And this is about the data scientist of sector page, like what are the different sectors there which require people who wanted to work in the data science and wanted to explore in the data science field. And this is the market today in 2023. You could see so many offers are available, so many recruitments are happening, which is going to provide you a very good career for the people who explore a lot in case of data science projects and machine learning. So you could see the trend is also very nice if you could see about the scope of data science and machine learning. So with that, I end my session.
Thank you, Kavita madam.
Yeah, thank you, ma'am.
Dear participants, do you want to communicate or you want to wish any queries? Please unmute yourself and you can ask the queries. Dear participants, please unmute yourself and you can ask the queries. Do you want to wish Professor Kavita madam? You can communicate with her. And maybe your presentation is very clear to them, I think so, madam.
Thank you, ma'am. Thank you. Thank you, all the participants also. I thank the
Okay, thank you,
coordinators
madam.
and the convenience.
Okay, thank you, madam.
Thank you
It
so
is
much.
really very interesting, and I think it is very useful to all the faculty members and research scholars. So who are started their research in artificial intelligence, machine learning, and deep learning. It will be helpful to them. And in this, initially you started with the sources of the data science, and after that, how it will be related to artificial intelligence, machine learning, and deep learning. And next, you slightly move to the data science process and examples, and how to calculate the hypothesis testing. And after that, you move to machine learning and, and what are the different classification techniques and tools also explained. So very nice, madam. I hope it will be helpful to all the research scholars and faculty members. Once again, thank you, madam.
Thank you, ma'am.
Thanks a
Thank you so
lot.
much.
Have a nice day.
Thank you, ma'am. Thank you so much.
Thank you.
வந்தாங்களோ மேடம் மண்டே வந்துருவீங்களா?
Please, dear participants, please mute yourself.
மண்டே வந்து ஓகே நான் மண்டே அப்போ வந்து செக் பண்ணிக்கிறேன்.
Welcome, Dr. Sanjeev Sharma, sir.